So I'm Sofia Höglund. I worked at Spotify for 4.5 years now, doing mainly test automation on iOS. And I'm going to tell you a bit about that. I'm also the only one using PowerPoint for my presentation tonight, so apparently I'm a hipster for that. Bug prevention, that's kind of getting all the hype in the testing circuit nowadays. And that's what we want to do as well, because we want to prevent the bugs from entering the master branch instead of detecting them afterwards. And I'm going to show you some examples of what we've done to actually achieve bug prevention. Have any of you seen this testing pyramid? Basically, as I said, it's one way of looking at it, and it says that unit tests are fast, so we can add lots of those. System tests or UI tests or end-to-end tests, on the other hand, are usually slower, so we can't have as many of those as we would like to, because time is money. A couple of years ago, we were kind of closer to an ice cream cone instead of a pyramid. And we are slowly moving towards the pyramid shape, but we're not there yet. And we kind of started in the wrong end. We started building system tests. In the very beginning, we barely had any unit tests. We definitely had no integration tests. And we started building system tests. On the other hand, we've been doing this for quite a while now. And we have kind of an interesting setup. So I'm going to focus on that tonight and tell you about how we do our system testing. This is our testing strategy, just a quick run through of it. So basically, most of you are devs, right? So you have your fix locally, or your new feature, or whatever it is. You build it and test it locally, whatever way you want to. But as soon as you push it, or if you send a pull request, we will trigger a bunch of builds. And among those, we will run pre-merge tests or pre-commit tests. System tests. Of course, we also run unit tests and other kinds of tests. But for system tests, we have the requirement that they should take less than 10 minutes in total. So we can run in parallel and have lots of tests, but in total, it should take less than 10 minutes, because you don't want to wait 10 hours until you can merge your pull request. If these tests fail, it's stop the line, you can't merge. If they're green and you merge your stuff to master, we will trigger another set of tests that we call BVT, or build verification tests. These are kind of broader. The pre-merge tests are very, very basic. They barely test anything but the very most important parts of the app. For the build verification tests, the requirement we have on them is they should take at most 60 minutes. Unofficially, we try to keep it under 30 minutes. These tests are a bit broader. They are still kind of smoke tests and kind of basic, but we try to cover most of our features. If these fail, we create a blocking bug report for it. If they are green, on the other hand, we're free to release to employees and to beta users also. And then we have a third set of tests that we call supervised tests. These are mainly like performance tests or stress tests or maybe long-running tests or things that don't fit into the build verification or pre-merge tests. And also we call them supervised because we don't have any kind of stop the line policy on them. So some human needs to look at the results and interpret them. If everything looks good, we're free to release to the App Store. And it's the same for Android, for Google Play. I did some number crunching. And it turns out in the past 7 days, including the weekend, we ran around 700 pre-merge tests. We ran over 25,000 build verification tests and over 42,000 supervised tests. And these are on iOS only. So as you can imagine, this put some kind of pressure on our CI pipeline and our build agents, all the supporting services we have for our testing, and also on our devices. So we see this happening every now and then, and I have a device graveyard on my desk with dead devices. The architecture. So this is the architecture we have for the system tests. First of all, a fair warning. They are written in Java. And this is kind of the reaction I've seen from some of the iOS devs when I've told them. And the reason it's like this is basically legacy. In the very beginning, 4 or 5 years ago, we started writing system tests for desktop. And in that case, Java is perfect because we wanted to run on all platforms. So we built all the supporting services, all the libraries, and everything we needed. And then a couple of years later, when the mobile-first era came, we wanted to add some iOS tests and Android tests. And by then, it was very easy to just add some tests to the already existing framework, which was in Java. And now, 3 years later, or 4 years later, we have so many tests in Java, so it's kind of hard to move away from it. And also, we've built it, so it's now kind of stable also. So starting from scratch would be hard. But we have looked into things like UI automation, Appium, and now UI testing. And we have some KIF tests also. So we'll see what happens in the future. But for now, I will tell you about the architecture for these Java-based tests. So we work a lot with test interfaces. On top of the client, I'm not calling this UI tests because we're not actually testing the UI. We have test interfaces that have methods like press the button or return the list of tracks in this playlist and things like that. We communicate with JSON data with something called new remote that I will get into soon. We also have some supporting services, test result service and test data service. So these test interfaces can be built on a view controller, view model, some kind of state machine, or basically any class you have in the client. So that's why they're not specifically UI. But that also makes the test much faster. And also, we can get and verify inner states of the app and not just the UI. So if we look at the new remote protocol, this is what we use to communicate from the tests to the app, and it makes it possible to run the tests both on simulators and actual devices. Basically, what we do, we open a TCP socket, and then we send strings. And if you see in the yellow box, you can barely see it, but in the top box of the UI, that's an example of a string written in new. It's a Lisp-like language. So it's basically just a string with a whole lot of parentheses. So in our Java framework, we translate, because in the tests we only speak Java, and then we translate it in the framework, so it becomes these strings. And then on the client side, it's translated into Objective-C. And that's what this new remoting GitHub project, there's a link to it. Some of you may know Nevin. He's the one who wrote it. So we know about the communication. Let's have a look at the actual test interfaces. I have one example, which is it's the album view. So we try to keep the interfaces small. They shouldn't contain any logic. Also, the only requirement we have basically is that they should have one method, one public or class method that returns the instance of itself. In our case, we've defined that as the currently visible instance. So if we're not on the album view, it will only return nil. So we can use that also to verify if the view we're expecting is actually visible. There's some magic going on. We're using annotations a lot on the Java side. The basic reason for that is we have different style guidelines for Objective-C and for Java. And we want to stick to them on both sides. And we also do some magic when it comes to parsing the JSON. So in the Objective-C interface, we only return a string that contains JSON. But on the Java side, we actually build these Java objects. So in this case, it's a JSON containing album info, which could be like the URI, the album title, the artist name. And so in Java, we actually have those objects. So we use an object mapper to parse the JSON. And it also requires some magic when it comes to lists. So we have to specify what kind of element the list contains. But that's pretty much all there is to it. For the supporting libraries or services we have, there are two that we use a lot, the test data service and the test result service. And both of them are basically just databases. For the test data service, we use it to fetch test users. We have a user pool with, I don't know, a couple of 100 users that we have set up. So they are live users, but they're only used by us. And also we have the test result service, which is just a key value database where we send a whole bunch of data, like pass, fail on the test duration, and if there's any kind of data we want to log and measure, like see trends and stuff in tests. So we've pretty much looked at everything except the actual tests now. So let's do that. We have two types of tests, scripted and model-based. And I will show you some examples of those two, so you can see the difference. First of all, scripted tests. These are the ones we use the most now. They are pretty much, they look like any other test, like a unit test. It's just step by step, do this, do that. In this example, you probably can't see everything, but it goes to different contexts, like an artist, album, playlist, and tries to start a radio station based on it. And so they should be small, deterministic, and they're fairly easy to get started with. So if we were to test the exact same thing, but using a model instead, it would look something like this. So in this case, we do the same thing. We go to an artist, we go to a playlist, and we go to an album and start a radio station on it. The difference here is we use something called Graph Walker to generate this sequence of how we walk in the model. So the difference is, like the first time you run it, you might go to an artist first, then a playlist, and then an album. But if you run the exact same test again, you could go to an album first, then a playlist, and then an artist. So it tests and verifies the same thing, but it does it a little bit different each time, which makes it powerful in a way, but less deterministic. So just a short summary. The scripted ones are easier, more deterministic, and usually faster. On the other hand, model-based are usually more powerful, but also more random. So if we go back to the strategy that I showed you before, for the pre-merge tests and the build verification tests, we only use scripted tests for those reasons, like they are more deterministic, and that's exactly what we want for those tests. We want it to be easy to reproduce failures if something fails there. For the supervised tests, we use both scripted and model-based because that actually fits in there to have a, like we could do exploratory testing or performance testing, and the model-based testing fits perfectly for that. That's all I had to say.